So the next chapter that we're going to cover in this course is chapter 3, matter and energy. So this is really basic stuff about chemistry. So matter that we've talked about a little bit before is anything that has a mass and occupies space. So matter makes up all of the things that we use every day, including water, wood, plates, clothes, etc. Okay, everything is made up of matter. And uh, all of the matter is classified by their composition. Okay, so matter can be a pure substance, which is made up, or can be two different kinds of things, either an element or a compound. So a pure substance is matter that has a fixed composition, so its composition doesn't change. There's two different kinds of pure substances. Elements are the simplest type of a pure substance, and it's composed of only one type of material, like silver, iron, or aluminum. So elements are what are listed on the periodic table. Elements themselves are composed of atoms, and atoms are tiny particles that make up all types of matter. So, for example, if we look at the examples we just talked about, silver is made up of silver atoms. Iron is made up of iron atoms. So for it to be considered an element, it's composed of only one type of material. So that's important to remember. Compounds are a type of pure substance which consists of atoms of two or more elements. So one of the most basic examples is water. So the chemical formula for water is H2O. So water consists of two atoms of hydrogen, which is H, and one atom of oxygen, which is the O. So no matter where you find water on the earth, it consists of two atoms of hydrogen and one atom of oxygen. So a compound is just anything that contains the atoms of two or more elements. So the next thing we're going to talk about are mixtures. So mixtures are something that you see every day without even realizing it. A mixture is just a substance that's made up of two or more substances that are physically combined. So examples include the air we breathe, which is a mixture of several gases, mostly oxygen and nitrogen. Okay, so that's one example. Steel is another example. So steel is a mixture of iron, nickel, carbon, and chromium. Okay, so those are two different examples of mixtures. So mixtures, unlike compounds, can have variable composition. So compounds always contain the same number or ratio of atoms, but mixtures can have different compositions. So for example, we're going to use sugar water as an example. So let's say in cup A, you put um, 2 tablespoons of sugar in 1 cup water. And in cup B, you put 4 tablespoons sugar in 1 cup water. Okay, so both of these cups, A and B, are both a sugar water mixture. But cup B is going to be sweeter than cup A, right? Because it contains more sugar dissolved in the water compared to cup A. So the variable composition means that you can have more of one substance in the mixture than the other. And mixtures also can be separated by physical means into their components. So compounds can be separated into elements, but they can only be broken down by chemical processes. Mixtures can be separated by physical means. So one example is filtration. So filtration means that you could separate a solid. So let's say we have this funnel and we're filtering it into a beaker. And we put our filter paper in, so that's going to be represented by that. So our filter paper is in the funnel, and then we pour into the funnel a mixture of sand and water. So what's going to happen when we pour our mixture of sand and water through the filter paper is that the solid sand is going to be left on the filter paper and the water is going to filter through. So just like when you make coffee in the morning, or if you make coffee any time of day, really, the coffee grounds stay inside of the coffee filter. So it's the same concept. You're just filtering the water through the grounds in order to, get the flavor of coffee into your water. Okay. So there are two different types of mixtures: homogeneous and heterogeneous mixtures. So we talked about this in lab a little bit. So a homogeneous mixture has a uniform composition. So that means that you can't tell the difference between each of the components in the mixture. A heterogeneous mixture is non-uniform. Okay, so a heterogeneous mixture would be something like the sand-water mixture that we just talked about. You would be able to tell that there was sand and water in your cup or whatever you had it stored in. You would be able to see the sand separated out from the water. So some examples of a homogeneous mixture, or one with a uniform composition, would be something like salt water, or Kool-Aid. So when you make Kool-Aid, you add the powder and sugar to your water. But once you mix that stuff together, the sugar and the powder both dissolve, and you can't tell that you added 3 different things to make your Kool-Aid. You just see the final Kool-Aid solution. Heterogeneous mixtures are things like oil and water. So if you've ever tried to mix those two, you know they just separate back out. Or something like a chocolate chip cookie. So when you make a cookie like that, you can see the chocolate chips and then the actual dough part once you bake it. You can see it before you bake it too. So either way, a chocolate chip cookie is a heterogeneous mixture.